Test 1, 2. Test 1, 2. Test 1, 2. The stream looks fine. You can pop it up on your laptop. Just make sure you gotta change the title and stuff of the stream. So can you log on your laptop?
Okay.
And just change the title to come to a 5 review session. That's gonna see.
Was the second exam a lot easier than in person?
This exam for me was a lot easier than the Stata and Excel exams. The thing about this exam is it's all concepts, right? You don't need to like remember formulas or anything like that. I mean, you didn't really have to for the other one either, but like this one feels more like you're just writing essays and like the question style. So did he tell you guys the question format or the exam format? Okay, he told me it, so I'll let you guys know it. Also, like during this review session, there's a lot of like some terminology related stuff that's new to the course. Like some of the terms we didn't cover last time because last time this content was only 1/3 of the course. This time it's half of the course. So like he added some more content and I'm familiar with it, but terminology wise, like it's just little nitty gritty acronyms and stuff sometimes. The main like success point during the exam is like you probably already have enough intuition and common sense, and if not, we're going to help you get that intuition and common sense about the concepts. and then you gotta use that and then throw in the right like buzzword with it, like oh yeah, like transaction processing system type thing is like relevant. Just like finding where to put the relevant idea is one of the hard parts. Let me tell you guys what the exam.
Possible to like fail this exam?
Not really. Yeah, no, I know what you mean, but like, even if it's something you have no clue what the right answer is, you probably have some idea of even how to give them an answer, which is better than not giving an answer at all. So, like, use those skills of making up stuff you've generated over the past couple of years when you're writing the exam. No, not really. Not extensively, at least. You just need to. So, the entire problem that people had with the NetSuite assignment and stuff is they weren't doing it right in a way. People like so that assignment I didn't like personally so much because it felt like he's teaching me how to read an instruction and click a button, right? And that's probably what a lot of you guys did. You literally just like click the buttons. But upon talking to him, that's totally not the purpose of the assignment. You could have submit stuff that didn't look exactly like what he wanted. The point was to see what an ERP can actually do or what FileMaker Pro can actually do. It's like showing you, like with the NetSuite ERP assignment, right? You can be all these different roles. You can be like the stalker or the like manufacturer or whatever, but it all can be done from one system and it can all be managed. So the exam format is, let me pull it up.
Do you have much difficulty with this one?
Not so much. Not with this one. This one is like, yeah, it's not so much memorization. It's more just using your conceptual knowledge and your knowledge of like what actually these things' purpose is. Like, what's the actual purpose of a project manager, or like, why would this project potentially go wrong, or things like that. So it's more concept heavy. So today I'm going to be reviewing the concepts and trying to help you make sure you know all the learning goals of the course. So the exam format, you might want to note this down. So the first part is 20 questions of true or false, and that's worth 20% of the exam. So 20 true or false questions. Second part is multiple choice. It's 40 multiple choice questions. That's 40% of the exam. Those ones are kind of going to be terminology related. So like there is an extensive amount of terminology in this class, and some of it is like similar acronyms, right? So try and make sure you're familiar with the terminology and what each acronym kind of means. A lot of times you can use some intuition to just guess on the multiple choices because some of the options are clearly not it, but some of them are pretty tight. So make sure you're familiar with the terminology. So that's 40 questions, this is 40%. And then part 3 of the exam is the part that I enjoyed the most. There's 10 questions, but you choose 8 of them. And they're short answer questions. And that's the last 40% of the exam. Biggest piece of advice he told me to give you guys when writing the exam is make sure you use your time wisely. I believe the exam is 2.5 hours, and it's done on Connect, like it's written online. So don't spend a bunch of time doing like thinking about a multiple choice question when you could be using that same time to write an even better answer for your short answer. In all honesty, I would try and start with the multiple choice because that'll remind you some of the terminology stuff. You may actually like remember stuff as you're doing the multiple choice. Then go on to do the short answer and using the terminology and stuff you just got. And then do the true or false because the true or false is only 20 questions. You can do those pretty fast. Yeah? Okay, yeah. Short answer, it's like small essay, like 2-paragraph essay type things. I forgot, it'll tell you the exact length, but it's something like 1 or 2 paragraphs. Don't spend like 20 minutes on one of them. Like some people will pigeonhole on one, and then you realize you gotta write 8 of them. Don't run out of time, and don't be overly verbose, right? The thing is, the longer your answer, the more room there is for you to be wrong, right? So just try your best to get it out as quickly and concisely as possible, and give them the least to like be like, does this person really know type thing. Okay, so the structure of this review session is this package. I went through all the slides and I took the learning goals and I literally just answer and teach you the learning goals from each slide. Okay, wow, I probably got to make this, yeah, okay. So the first learning goal, introduction to BTM, business technology management. So define business technology management and why we need to study business technology management. So BTM is the set of processes and services that an enterprise has a lot of technology within it. An enterprise just refers to like a large business or just any business for that matter. And they have all these different processes and technologies that they're implementing to make their business work. How do you take care of all of these together? Because there's so many different components of what a business does and what their processes are. Like if you're a grocery store, right? Just think about it. You have all your cash registers you need to manage. That right there is a component of the business technology of this store, of this enterprise. So this is the study of how to manage all the different processes that a business uses to operate. So yeah, as I say there, like literally every single business these days in 2017 has some form of technology they use. Some may be super minor and it's irrelevant, but like even the corner store on your street uses some sort of technology. So how do we manage that? And then discuss the role of business managers in technology adoption and development. By the way, like in terms of notes, like there's not too much to write unless you want to just make sure you know the little concept. But the review package itself has most of the stuff that I'm going to be going over written for you already. So I'm just going to be adding to that. So the role of business managers in technology. Okay, so a problem that is happening is that a lot of businesses, the leadership and the management is old school per se. Like the people at the very top, they don't know enough about technology. So the role of business managers, where they come into play, is they know how the technology operates and how to best use it. So business technology managers in a company, they guide the direction of the technology usage in that company and try and resolve those gaps in the knowledge. For example, a big issue that you can see in a lot of companies is that when it comes time to like buy new laptops or buy new technology for the company, as like the like manager or whatever, you're gonna think, yeah, I'm the manager, I deserve like a brand new MacBook, right? But who's the person who actually needs a lot of computing power? The person who's actually using their laptop to like manage a bunch of Excel spreadsheets or like use a database. The person at the ground level is the one who would actually benefit the most from that laptop. So a business technology manager in a company's role is to help make sure they know how to best use the technology resources in a company. Now the 4 critical dimensions of BTM, you're probably going to have a multiple choice question on this. It's kind of just a memorization type thing. So the 4 critical dimensions of BTM are processes, organization, information, and technology. All of these things are what you learn about in the course. So processes. A process is how a company is able to take almost raw product, raw data, or whatever it is, and come out with their end goal, their output. So be it a service, be it a product. And BTM is all about maximizing the efficiency and the effectiveness of these processes. How do we do what we do as best as we can, as easily as we can? And that comes through things like that we'll learn about such as automation and optimization of existing processes. Organization, so scope, there's multiple different levels of hierarchy in a company. So like the managers, the like actual employees at the ground level, middle management, and then the executive suite. So how does technology apply to each of these? Then there's this concept that on that slide about organization, about the three bodies. So there's the participative bodies, who are the ones who are like using the technology almost all the time. There's the centralized body. Isn't that needs-based? Review the slide as well, but I'm pretty sure that you can review the slide on that one. I won't misinform you, so I won't go in depth on those three then. Mhm. So to avoid further confusion on that, you can check the slide on those, and I won't go through those three, but those are the three concepts you should have for potential multiple choice answer. Information, so the concept of information is a big component of the course, like data versus information, how it's processed, how we keep it secure, integrity around data, and then technology. Technology ties all these three things together, and it's how we connect processes, organization, and information using technology.
Is there a hierarchy for that?
For technology?
No, for the
So the main like hierarchy per se is so processes, organization, and information. They're all like there's a slide on it, but they're all like independent. But technology is the thing that like wraps them all together. There's no like explicit hierarchy, and that's not something that you'd be tested on. But technology is like the most important component of that for this course. So business processes, information systems, and information. So what is an information system? So a question you're probably going to get is like, what's an information system versus information technology? Information technology is straight up just the tools, like what we actually physically use. Whereas an information system is a combination of multiple factors, one of which is the tools. So it can be the hardware tools like the actual keyboards and like computers use, the software tools like NetSuite ERP, the network itself, like how we actually connect. Like within a big company, you may have what's called an intranet. So it's like not internet, it's just an internal connectivity network. The data itself, and in regards to information systems, data is literally just like the facts that they process. So like for a finance company, the data could be like literally the stock prices, right? The processes and procedures, how they really manipulate that data to come to the outcomes that they need. And then the most important component of information systems, you may have a question on this, is people. So without the correctly trained people or the correctly knowledgeable people, information systems are useless, right?
Would you say like business process breaks down into IT, but IT surrounds like IS? Like without,
So
you know what I'm saying? Like,
IT is a subcomponent of IS.
so IS is the
Information systems. So it's a very general and broad term, but an information system is literally in a company. The information system is like all encompassing of almost all of their technology.
so like a system isn't just something that's online. A system.
Right? Yeah, a system is just like referring to what the company does entirely. It's almost like referring to their business technology management. The term is information system. So that encompasses their hardware, their software, the people who are involved with it, and the actual processes they use. So IT fits into that in a component of their hardware and software. And yeah, as I said, it enables the people who know how to use it to use the technology. And without the right people, it doesn't matter. And then this is a terminology related question, but data versus information. By the way, I'm assuming you guys have had the chance to check out. Professor posted like 30 review type questions, and those are also a component of what this review session goes over, because those are the big concepts you need to know. He's not going to directly ask you those questions, but those concepts are exactly what's going to be tested throughout the exam, plus or minus some terminology. So data versus information. data is the raw, unprocessed, like the stuff you physically collect, like a bunch of transactions. Whereas information is data that's being processed, that it's understandable for a human, that you can actually conveniently and easily use that data that's been processed to make decisions. And so a good information data system is fast, it's user-friendly, it's inexpensive. And at the end of the day, we use technology to make lives easier. So any sort of technology implemented with a company, the end goal is that it makes the business's processes easier. It optimizes them. So now explain business processes and discuss the importance of business process management. So a business process is a structured activity or task that is used towards a specific goal. Would be that creating a product or providing a service to customers. And business processes aren't just limited to the scope of BTM or Bucks or this class. I mean, finance has business processes. Accounting has business processes. Business process is just the flowchart and the sequence that a business uses to accomplish whatever they do. So, as mentioned previously, this course is really about how do you optimize those business processes. And what does optimize mean? It means to remove things like bottlenecks. And that's definitely a keyword that you can throw into your short answers. Like a bottleneck is some process that has an inefficient point that causes that process to become useless or slow down severely, like needing to wait on one person. So bottlenecks, redundancies, and to combine related activities, right? Why not just do everything together? So that's a big component of what it means to optimize a business process. So the business processes that are in the highest risk of being inefficient are cross-functional business processes. So what that means is if like the sales department needs to do something with the like actual inventory department, right? The stockers, how do we make sure it flows smoothly? That's where things like enterprise resource planning systems come into play, right? ERPs is how that stuff gets managed, and that's like one of the ways we optimize a business process. Another really important process is anything that's customer facing. So you want the customer to always have the most amazing, best experience. Any process that causes trouble for your customer is like a huge red flag because you're gonna lose your main. Yes. Go for it. Yeah, you're gonna use your main source of revenue.
So like a value chain
Yep.
has multiple business processes.
Yes.
And a value chain, for instance, could be like one business process could be making a pencil.
Yes.
And another business process could be making a pen. And
Yes.
that all fall under the company's value chain, right?
Yes.
And under a value chain, could you say you have a cross-functional section for each business process?
Yeah, you could definitely like the value chain itself can be cross-functional entirely. It
So,
can,
like,
yeah.
A value chain can be encompassed by a cross-functional process.
Yes. So, yeah, I think I get what you're trying to get towards in terms of the scope. The entire value chain of a company, for the most part, is generally cross-functional. Like that's almost a given for anything, in that there's a lot of different functions of the company, different arms that are needed for any value chain to be successful, right? And then the business processes within them are also cross-functional. But generally, you're going to use cross-functional, not to refer to the value chain, but yes, the processes are cross-functional processes.
And then just to break it down further, so there's business process and then there's your process.
Sorry,
Then
and
there's a process,
Yeah.
and there's sub-processes, and then there's activities. What's an activity?
so an activity is the like lowest level of things. It's like the actual making the pen.
Would that be like making the pen, or would that be getting the resources to make the pen?
So that's like, yeah, I guess if you're factoring it down to the lowest thing, but this isn't the kind of thing that like is tested.
You know?
Like are you saying are you worried of something like differentiate whether this is a this or that?
You know, like he didn't have anything on his slides regarding like to give an example of a business process and process and a sub-process, or
Don't think it's going to get that nitty gritty because that's just like mean of him to try and do that if he hasn't given extensive examples. Like I looked at the same slides you did and like, yeah, I think that's off the table. But you should know like the hierarchy and that like an activity is a sub of a process. What are the components of the value chain? Yeah. Yeah, and then it would be like I can imagine that's a multiple choice and they'll give you like 4 different ones and like one of them has like the wrong thing in it, that kind of thing. Like you'll get a lot of those. Like it'll be like BTM, like what does BTM stand for? And it'll give you like business technical management instead of business technology, like that kind of crap. Like be wary of those. So make sure you just read all the things that have acronyms or anything like that really carefully so that you're not confusing small things.
even like stuff that you guys like much like because there's some like I don't even know the acronym for them, there's different systems.
Oh yeah, so you're gonna need to. We'll go to that like management information, executive information systems.
Yeah, like that.
You're gonna need to know those. Yeah. Yeah, and that's what we're going towards next. So there's 3 different scopes of a business process. What that means is who is that business process really for, or what process is that directly related to? It says transaction processing systems. So those are the lowest level type systems. It's literally for the business's transactions, which is like the selling of the pen or whatever it may be. So that's the lowest level, done daily, one of the most crucial systems within the company. Then there's management information systems. They're used less frequently, and as implied in the name, they're used by the management, and they're used to determine how to allocate the resources of the business. Things like scheduling or inventory related things, really important to the operation of the business. And yeah,
Did you say NetSuite is a function of PPS?
it encompasses almost everything. Like that's the beauty of an ERP is that it's used for so many different components. It can be used for everything. So you wouldn't be asked something like that, but you may be asked for like one of the components of NetSuite. Like is it an example of a transaction processing system? The like generating an invoice type thing. Okay, I don't.
Because the point of PPS is like
Your daily activities, right?
to have like records and all
Mhm. Yeah, definitely. So it's a component of it, but NetSuite also gives you even more capabilities of like looking at all your data and all your like audit history and that stuff that can be used by management. That's a component of a management information system. So I don't think you'd be asked stuff specific to business process, or you may be asking like, how does NetSuite or how does the enterprise resource system optimize business processes? I think that's a pretty fair game question. That's something you should be capable of answering. And then when answering a question like that, it'll benefit you to then throw in one of these, something like transaction processing system, something like management information system within your answer for that to show you have more conceptual knowledge of business processes. So business process management is the continuously optimizing the processes that you already have with the client's needs in mind to make them even better. And as previously mentioned, the key components are efficiency and effectiveness. Then if you have some time when you're at home, there is a very good video. I've just included the name on here. Just YouTube it when they're like 3 minutes each, so you have the time. When potentially given a business process, off the bat, you should be looking at, are there any redundancies present? Is there some sort of inherent bottleneck? How can we eliminate that bottleneck? Is there a redundancy? If you may be given a question that describes a business process as a short answer. You should be feeling comfortable about, can I optimize this process? Can I inherently and easily identify that there's something wrong with what they're doing? And I think you're all quite capable of that and will be capable. Yeah? Is that a question? Yeah, for sure. So it's the level almost of who uses it. So a management information system is for almost like shorter term resource allocation, like literally like scheduling who like shift management. Like a shift management software is an example of a management information system. Like at a retail store, like it's a key component for the management to use to determine how to allocate resources. Whereas an executive support system is literally, should we open a new store here or not? Should we close down this store? Should we change the store to include this? Like it's for more large scale decisions used less frequently, and it'll generate things like organization-wide reports, like where is our company doing the best, our western sector, our eastern sector, that kind of thing. So you're likely not going to have too much about that. But acronyms, again, you may be asked acronym questions about this, like TPS versus MIS versus ESS, what do they all stand for? And just know that kind of stuff. That's a very easy, yeah, that could be in the multiple choice. Or something like a true or false could be like management information systems are used to make everyday decisions, right? That kind of thing in true or false. I could expect that. Introduction to enterprise resource planning systems. So explain the purposes of transaction processing systems and its relationship with other information systems. So the definition here, transaction. A transaction is any business event that generates some form of data that is then recordable. It could be a sale at a company. It could be a purchase at a company. It could be hiring someone. These are all different transactions, business transactions that are to do with the everyday operation of a business. They then get stored in a database. So this unit also ends up covering databases just a little bit about some of the important things of a database and what it tracks. So one important concept of a database is to allow concurrent updating. What that means is something like if I wanted to edit the price of something and Amin wanted to edit the price of something at the same time, we won't run into a problem, right? So that's what it means to allow for mutual exclusion and dealing with those collisions. Then protected from inconsistencies because of failure. If something like one person's computer dies, the entire database doesn't get messed up. Like if mid-editing, your computer shuts off, nobody else's thing gets affected by that. It's modular almost. Pardon? So protected from inconsistencies because of failure. This is just straight off the slide as a point. All transactions must be reversible. So if you change the price of something, we should be able to easily go back and change that. And then the last component is all transactions must contain an audit trail. Once you change the price of that, I should easily be able to see that this price was changed by Ahmed. So this encompasses transaction processing systems in that it records all these transactions. However, the data from these transactions can then be used as components of management information systems as well as executive support systems, because you look at it in a bigger scope. I can do things like from a management's perspective, is like look at who's been doing the most sales using this enterprise resource system. I can use that audit trail component of the audit trail it generates to track these kind of things and make decisions as like, hey, we're going to fire this person. And then even further, from an executive support system, like, hey, if this model of car is selling the best in this region, let's try and do something with that. You're able to use and manipulate the data generated by transactions from an enterprise resource system, enterprise resource planning system very easily. So that's how these different systems are just different levels and they encompass each other. So transaction processing system is the very lowest level and it's the one that gets used the most. Then the data from that and what that has tracked all the transactions from it and the audit trail can then be used further in the scope of these other business processes and these other information systems. The point of an information system is just that, to provide information that can be used by decision makers in the company and make it available. So, other very important requirements of a transaction processing system, and by extension, we're also encompassing these terms towards databases. These are all important of databases. Performance needs to be fast, right? What if you're trying to sell something at the Gap and it takes like 30 minutes for your transaction to go through? Availability, if there's any downtime, like think of some very critical systems, a hospital's patient management system, whatever they use. That needs to have like 99.99999% uptime. If that goes down, you're in a pretty bad situation. Whereas if a store's like system goes down, they're just going to lose a ton of sales. So that's what availability refers to, uptime of the system. Integrity of data, some stuff is super secure, right? Patient information, like there's so much security around that. How do we make sure that data stays in the right hands? And then easy to use. So I think that's pretty straightforward as to what easy to use means in this context. It must be user-friendly. Somebody should be able to go on there and understand how it works, because you're going to have to train so many employees otherwise as to how to use the software if it's not easy to use. And then modular growth. This one is a little bit more technical of a concept. Modular growth means if I want to improve my system, I don't have to shut every other component of it down. I can just build on what I already have rather than have to scrap everything and add more. Does that concept make sense? Okay, cool. Describe and just, yep. Yeah, exactly. So you don't have to go down to make it better. You can just add components to it. That's what modularity means. Like, think of it like a Lego brick. You can literally just like add it. Like Lego is the key example for being modular. Cool. Describe enterprise resource planning systems and their associated benefits and challenges. So what an enterprise resource planning system does is, rather than have different silos of information for each department, it encompasses it and aggregates it all into one, ideally very easy to use system that's used across all different functions of the business. As you saw with NetSuite, almost every different role in the company use that. So what this does is it eliminates redundancy, first off. Rather than when an order comes in, right? When a sale is made, every department can, instead of having their own copy of that sale per se, and have that data newly generated within each of their silos, it can all be accessible on one. In that the accounting department, to create the invoice and stuff, they don't have to track it on their own. They can literally just go in and see the sale's being made. Now, do I have to track it or not? Like, it eliminates the redundancy of having to keep track of that same order in 3 different departments. Instead, it's all in one, and it's all the same one. In that, the accounting department can see that this department's already made whatever they need to make, or like it's all in one place, and you're not having it redundant. It all points to the same record. I think I explained that pretty poorly, but does that concept make sense in that it's all the same one? We don't all need to test the same, like water. We all just have one bottle, and we can all write on that one bottle instead of each of us having the same bottle of our own and then needing to merge it together. Exactly. So Google Docs, like, that's definitely an example that you guys can definitely relate with most. It's not an example of any of these, but it has a lot of the qualities of these. Things like with databases, with collisions and stuff, it allows concurrent. So like Google Docs has all of the things of like those 4 A, B, C, D at the top. It has all of those encompassed into it. So it has concurrent updates. You and I can both edit a Google Doc. It has protection from inconsistencies as a result of failure. If your computer dies or your internet dies, my document doesn't get affected. All transactions are reversible. You can just Control Z any transaction. And an audit trail. You can literally see all edit history on a Google Doc. Think of that. If that helps you put it into scope as to what they want from it, that's what they want. An enterprise resource planning system is like a giant Google Docs type of thing for an entire company for all their business processes. Cool. So a big component of an ERP is that it creates this paper trail, an audit trail. You can see literally every transaction that's happened, who's done what. So this is super helpful for management. It's super helpful for executive planning. You can see who's doing what. And that's what it lets you track. So now, what are the difficulties of enterprise, of ERPs? So the main difficulty of ERPs is that every business has most businesses have different business processes. How do you apply this ERP solution to your business? Because your business may have some specialized process, or it just may not work to this. So there's like two main solutions. You can either tailor your processes to work for the ERP, or you can make sure you get an ERP solution that works best for your company. And that could mean making a custom ERP solution. So when solder graduates go on to work at companies like SAP, one component like SAP has a very big ERP system, and that's one of their big sales. So does Oracle and all these other big companies. So what these companies do is that they charge businesses a lot of money to make a custom ERP solution to their needs. And so that's something that you're probably going to take away from this course, is that ERP solutions are super expensive, but they can make a company's business processes way more optimized. And then the big problems with them is that they don't necessarily do exactly what the company needs them to do. So the solutions to that are you create a custom solution, you make sure you find the ERP that best suits your needs, because there's like a billion out there. And then lastly, you could just change your processes to match the way the ERP already works. So when trying to implement an ERP into a company, there are three main buzzwords that come into mind. Gap analysis. Know what that concept is? I remember when I was talking to the professor, he mentioned gap analysis a couple of times. So gap analysis is making sure you know the differences of what the ERP can do and what you're currently doing. So literally the gap between the business requirements and the technology's capabilities. Then customization. How much room is there with the ERP solution to make it change for our specific business processes? Customization, pretty straightforward on that. And then change management is the last one. So if you're a giant company and you're now implementing this brand new ERP system, not everybody's going to know how it works right off the bat. How costly is it going to be for you to put in this new solution? And costly doesn't just mean money. Costly means time. Because if you have like 1 million employees around the world and you're implementing this new solution, you need to train now 1 million employees. That's going to take a lot of productive work time that could be doing other things. So how easy is it? Another component is that like for this change management, will the ERP provider also help with that? Like SAP, they literally like set up sessions at your company to train your employees how to use their new system, if you were to use their new system. How do we manage that? And that's change management, and it's a factor when deciding as to which ERP system to use. Give me a second here. We're going to go up until IT architecture, and then we're going to leave the rest for after the break, because we're going to take a quick 15-minute or so break when we get to IT architecture and cloud computing. Okay, database concepts and managing data. Explain the importance of databases. So databases are definitely going to be tested on the exam. a bunch in different ways. So I'll explain some of the main concepts of a database. So one main thing you're going to be expected to know is what is the difference between a database and just using Excel, so a spreadsheet. Why not just use an Excel spreadsheet instead of using a giant, complicated database? Are you guys familiar with that yet? Do you want to answer that, or do you know it? Okay. Yeah, Felix, you know it? Mhm. Yep. Yeah. So that's exactly it. So one of the main benefits of a database, as opposed to an Excel spreadsheet, is the concept of it being. Why is the doc-cam not going? Oh, I don't want that there. Give me a sec. Is the concept of it being relational. So let's explain this. Let's try and draw this out. So, with a pen that actually works. ERP system, it has the principles of an ERP system. Because but remember this, at the core of an ERP system is a database. Right? An ERP system literally just, the transaction component is literally just processing database data, right? Every transaction generates data that is then stored in a database. So a database is really the core of an ERP. And the beauty is of having this ERP and database is that you're able to manipulate this database by everyone. First off, using like those principles we had earlier of what an ERP does. Right? Yes. So database is like the core of ERP. And that's what everybody who uses that ERP is actually touching. The ERP that like what the user sees and stuff, just the user interface component. It's like making it user friendly, but really as like a manager, right? If you're trying to see like, hey, so what has Amin been doing in terms of his like performance at work, right? That's literally just me like doing processes and manipulating the data already in that database to like see that subset of data type thing. So I'm gonna try my skills at doing a visual example between a database and an Excel spreadsheet. So here is a single Excel spreadsheet. It has rows, it has columns, and each of these cells contains data. Okay? Oh shoot, yeah, sorry. I'm really bad at this. I should probably not even use this. No worries, that's good now, right? Yeah? Cool. So this is an Excel spreadsheet. And this, it's going to fix itself in a sec, is a table. When it fixes itself, is a table, okay? So they look exactly the same, right? However, all the contents of the table in a database, almost all, come from other tables in a database. What that concept means is the concept of a database being relational. Rather than have the same data stored on 20 different Excel spreadsheets, a cell in a record rather, in a database table just points at another cell. So the data is just stored once, but everything else literally just points at that data. Does that concept make sense? Rather than have it stored a billion times in a billion different spreadsheets, we literally just have it stored once, and everything else just points. My drawing is going to shit, so leave the drawing. But like, it literally just points at that other cell. So what is why? So why do this? So we use a database when you have a lot of data, right? Like we're talking like hundreds of thousands of tables, millions of cells. If I wanted to edit a specific price or something, right? That price is probably also used in other different spreadsheets, like the price of like our main ingredient in like milk. Okay, so say we're a company that uses milk as one of our main like raw resources. The price of milk changes and I need to change it. I need to then, if I was using a bunch of Excel spreadsheets, I need to change it in a billion different places. Whereas this concept of it being a relational database, is that I change it in one place and everything else knows because it's all just pointing at that same one piece of data. So that is the beauty of a database, and that's the advantage to using a database as to using a bunch of Excel spreadsheets, is the concept of it being relational. Does that make sense? Other than front row, does that make sense, the concept of it being relational, whereas an Excel spreadsheet is not necessarily relational between a bunch of different? The other thing is databases have a lot more intricate features in that you're able to run a lot of processes over subsets of data. You're able to manipulate that data a lot more extensively. Because we do have like literally millions of records, we are able to like get subsets of that data or across a range of data do a function, right? We're able to manipulate a database a lot easier than we can manipulate data stored in an Excel spreadsheet. Other components of a database that make it more advantageous to Excel is concepts like access control. Who can or cannot see certain things in this database, right? Like credit card information stored in a database, you don't want an employee to be able to see that, but it's all stored in the same database that that employee is already using. How do we tweak that access? Well, that's already there. And then another component is data integrity. So what that means is if you have a credit card number, how do we make sure that we don't have letters in this credit card number, right? So data value integrity checking. So that's referred to as data integrity, but yeah, that's okay. Database management systems are what people actually use to manipulate and manage these databases. There's a billion different ones. FileMaker Pro is one of those. There's some other ones you don't need to really know about, but Microsoft Access, MySQL. SQL is a term you might not need to be too familiar with, but it was mentioned in the course. It's just a programming language that's literally only to operate on databases.
So would you say FileMaker Pro is that you can customize the way your data is?
Yeah, like it's a full-on database management system.
Is that the purpose of FileMaker?
No, it's a database management system. So it allows you to manipulate, edit, create, and manage a database,
And then,
a relational database.
what's the difference between NetSuite and FileMaker?
One is a database management system. You could take all the data stored in NetSuite and use it on a database management system, whereas NetSuite ERP is a process, like it's an enterprise resource planning system, so you can actually directly manage the processes. As like an employee at a company, you don't need to see this database. You just need to say that I sold this, right? So that just makes it's a user-friendly interface type thing. And it automates a lot of these processes, right? It literally, like, you put in your sale or whatever, and it just goes in and it knows how to deal with it.
So would NetSuite have its own database?
It has a database. I mean, like, it wouldn't have its own, like, system, like a FileMaker Pro or Microsoft Access. Those are just programs you can use to just manage a database. The files can be managed by, like, any of these. It's like saying Microsoft Word versus Google Docs versus OpenOffice. Like, they all do the same thing. You manipulate a Word document, but it's just the program you use. FileMaker Pro is just the program they use for this course because it's like easily accessible. Okay, so some of the jargon around databases that you might need to know. A row, as you would know it in Excel, a row going left like horizontal is known as a record. Column is known as a field. So each record, each row is information is logically placed there. So what logically means in this course is that it makes sense to be there, in that it has some purpose being in that specific row. What that really means, though, is that it's grouped by some sort of parameter. That parameter that they're logically grouped by is their primary key, generally. That primary key is often something like their user ID. So let's think of an example, right? So if you have this database that has like literally like account information, your CWL login information, as well as the amount of money you paid in tuition, right? So each of those records, each of those rows is identified by somebody's CWL login ID. That's the primary key. It's unique. Your login is not going to be the same as anybody else's login username, right? And that's how we can differentiate each and every different row. Yeah, they could have very different passwords, but there's still a chance the password could be exactly the same. So that's we talked about primary keys a bit in the during like stata and stuff, right? It's the same concept in here, in that it's just something that uniquely identifies a row or a record.
You have to identify
The primary key of something. Yeah, if they give you, they might give you like an excerpt of a like database table and identify the primary key on here. You know what that is, man.
you can do like
No, that's not a thing. That's data. Yeah, that's not a concept in. Pardon? So yeah. You basically the idea around foreign key in here is that almost anything that comes from an. I don't think that's something really testable so much on an exam like this. But what a foreign key is. Remember I was talking about relational, right? And how it points at something else? If it's pointing at something else, that something else is a foreign key because it's coming from some other database. Some other table. So you're not going to be asked to identify a foreign. I'm going to say that's like off the table because you're not going to necessarily be able to know if it's coming from somewhere else or not. The foreign key just means that it's a value coming from some other table. Yeah, like it's there, but the concept around primary keys is something can uniquely identify. And then another jargon type thing is atomic versus composite primary key. Atomic means literally just one cell can be used to identify it, like that student name or username rather. But if it was first name, last name, that's now composite because that's two different like cells, two different fields that are needed to uniquely identify it. See, that's another thing. Like, that's something that your database is going to need to enforce as a record. As a policy around your database. Can two people in your database have the exact same name? So then you might want to also include something more on top of that. And then even then, like, is that enough for it to be a primary key? Most of the time, they're not going to try and trick you up with something like if they give you first name, last name, like. They're probably not going to ask you for first name and last name as the primary key. It'll be more obvious than that.
Like, what if the example you using classes is trucker?
Yeah.
And like, let's say they give you like a trucking guide and they have to have an employee number.
Yep, employee number would be primary.
And first name and last name.
You would just need the employee number, right? Like you don't. That's.
So that'd be atomic then.
Yeah, that'd be atomic. Employee number.
If you put composite, then would be wrong.
Yeah, it wouldn't be wrong because you're still. Right, primary, but the problem that comes there is that the first name and last name might be coming from somewhere else, and then it's a foreign key, right? The first name, last name, yep. Oh, screen? Yeah, I'm listening. Yeah. Field refers to a column. And each column, right, is like a different type of data, right? It could be the name, could be the last name, it could be the employee number, could be the amount of money they make, right? That's what the fields refer to. Did I answer your question, Ben?
Kind of, so like on an example, so you're probably going to ask, like,
Identify primary key. Give the most simple answer. Always try and give the most simple answer. If it has an employee ID, just give the employee ID. Don't try and give all three of them, because then you're overcomplicating it, and overcomplication is not what they like. Okay, cool. Last one before our quick break. Describe business intelligence. Business intelligence refers to the information that is used to support decision makers. So, business intelligence is not something we covered so much, but it's because it's so broad, right? Like saying business intelligence, it includes a lot of different things. all the processes that a company uses, literally their data, the different technologies that they have implemented, the different applications, the hardware, the software, the strategies. Like, business intelligence's purpose is more what's important to you. Business intelligence is all the different things that a decision maker needs in their company accessible to them to help support their decisions. How do we, because just the data itself isn't necessarily valuable. We need the business intelligence as a whole. How can a company best use what they already have to leverage their advantage and to make those decisions that they need to? So there's three main forms of business intelligence, but I haven't gone in depth on those. Strategic, operational, and tactical. Operational business, wow, I haven't gone in depth on those, and I don't fully know those concepts. So I don't want to explain those to you guys. But those are three concepts you should be familiar with. I'm sorry about that. That's really shitty of me. But strategic, operational, and tactical. Know what those refer to in terms of business intelligence, because I can see potentially that coming up on a multiple choice, but it's not something that was covered too in depth. Apparently not in depth enough for me to want to go in depth on it on the slide. Next is describe the fundamental concepts of data warehouses, data marts, OLAPs, and data mining. A data warehouse is used to aggregate a logically collected set of information across the operations of a business. So, as we said before, like let's think of NetSuite, right? It has a bunch of different databases collecting like all these different components of information. Data warehouse is the aggregation of all of those. All of the databases that this company has is aggregated into the concept of a data warehouse. Tons of raw data, not too useful, right? I mean, not too useful to the everyday person in the company. Yeah.
Did you say a database is an asset to specific components in a company?
Yeah, I mean, databases are, as we said earlier, that they're logically collected, meaning you're not going to have all the information from some other sector in the same database table, right? Right, you definitely wouldn't want that. And that's why it's nice that they're relational and that someone else, you would, because if you have access to the entire data warehouse, you would be able to get all of it. But what the actual team for accounting, whatever, would have access to is the data mart, which is a subset of the data warehouse. Like all the information relevant to accounting, all those records, that could be a component of the data mart. It's the subset of the data warehouse used for a specific purpose. All a company's databases and their tables are aggregated into a data warehouse, whereas subsets are referred to as data marts, and those are used operationally. Yep. Pardon? Yep. Yes. Yep. Different subsets. Yep. Any subset of a data warehouse used for a specific purpose is referred to as a data mart. I don't imagine that being something tested extensively other than a multiple choice question or a data warehouse. True or false, which is bigger, a data warehouse or a data mart?
Did you say that it goes data warehouse to a data?
So yeah, data warehouse, data warehouse, data mart, and then databases. That's the hierarchy. OLAP, online analytical processing, or multidimensional analysis. This is something that was super confusing for me to even try and learn, to try and teach you guys. So beware. So think about a table, right? A table has rows and columns, or fields and records, right? What if we had another dimension? Another dimension that goes think of a cube, right? If we had this dimension of depth, we could then use just another way of aggregating our data. And we can look at more analysis. We can do more analysis because now we have access to more data that's relevant to our aggregation of data that we have. I don't expect this to be tested extensively. just these basic concepts of the fact that it's multidimensional, so it has a third dimension of depth to it. So like we could have this database that has first name, last name, and income, right? So think about that. So you have like 3 main fields. Then you have a bunch of different records, everybody in this classroom. But what if you wanted to see that income every year? So you could have another dimension that is the year that would then have, so each of the like tables within this like multi-dimensional like cube has the first name, last name, and the amount of money or their income, but it has it every year then. So we can do analysis this way, right? Yeah. You're not going to be tested extensively on that, but know the concept of multidimensional analysis. That's just like another like point that you can reference off of. Wow, that was pretty bad. There's a really good video on it, though. There's like a 5-minute video on YouTube, a little bit more technical than you probably need, but you probably don't even need much for this class. It just allows you to analyze over another dimension, right? Of time per se, of like income per se. Yeah. Data mining is actually extracting information from data. So as we clarified earlier, the difference between information and data is raw, just a bunch of transactions, whereas information is processed so that decision makers can actually use it. Then there's the concepts of drilling down versus drilling up. If you want something more specific, then you drill down, right? That makes sense. You like zoom in. Whereas drilling up is to get more broad, to get more summary based, right? To see like a trend over the entire data set is to drill up. Whereas if I want to see all the individual incomes of people born in 1997, I would drill down heavily. That concept's just literally zoom in, zoom out. Business intelligence dashboard, this is the last thing before the break, is business intelligence dashboard literally just aggregates everything into a user accessible hub that lets you see all these analytics. A good example of a business intelligence dashboard is if you're in finance or you're into finance, the Bloomberg terminals, they literally aggregate all this data. They give you access to all these different databases, make it usable, user accessible, and allow for processing of the raw data so that can be used as information. We're going to take a quick break. Miguel's going to give a little announcement about what you guys can do during this break.
Yeah, so this break, basically, for feedback, and if you fill out more,
There's like literally like 12 of you, so fill out the form and you have a chance of winning the gift card. Also, I appreciate the feedback. Thanks. And if you have questions, you can come talk to me. I know it's been kind of confusing. It's posted on the event page. It should be posted on the event page. How do you go from almost being there to now? Okay, so here's my idea is that we're probably gonna finish with like 30 minutes or so. So what I want to probably do is there were some particularly confusing sections. The slides are okay, but they may be hard to understand on your own without extensive googling. So we'll go back to those slides and we'll try and let's unconfuse you guys on the concept that you were confused about from the slide. So we make sure we're giving the information that the course gave you. So if you have anything that's particularly confusing you thus far, make sure you note it down. We're going to go into the slides after and try and fix that. I'll also have office hours tomorrow, I want to say. They'll be posted on this after, but I'm pretty sure they're tomorrow. I have like 2 hours of office hours. I'll just be sitting somewhere in this building waiting for you guys to ask me questions or studying for my own 4 finals next week. No, just 4 in a row though. Tuesday, Wednesday, Thursday, Friday. And then studying this. It's actually really hard to teach these because I mean I had to literally like relearn and go through all the slides again and ask the professor questions and stuff. Watch a bunch of videos. No, I've done a really good job at being confusing today. Okay, thank you. I mainly because like the main problem I had when I was trying to go through the slides like last semester was that some of the slides like you have to do a lot of reading on other things on your own if you don't even understand the concept in the first place. Like there's an assumed baseline of knowledge. That baseline comes from literally listening in the lecture. If you had a hard time listening to the lecture, then you're confused when you read the slide and you're in a bad situation. So I tried to clear that up. Lectures were good. I liked Wyand's lectures. He was very passionate. Wyand's a cool guy. Like, talk to him sometime outside of lecture. He's really like, he's actually really into this stuff. You guys are with me Saturday? Were you in the meeting the other day? I did last semester. I had yeah, a lot of people are saying like it's gonna be the death of them. Like they're scared that they didn't pass. Yeah, I mean, a lot of people are scared that they didn't pass, and either he's gonna fail a bunch, or everybody's actually just more scared than they should be in the market or this year. Like, yeah, yeah, like if a lot of people fail, then it's probably that stuff, right? Or the problem. I had a last semester. Yeah, because like obviously the school doesn't really like that. The school is the one that enforces that stuff at the end of the day. Once the exams are done and the marks are given, there's a time before it comes to you guys, and that time is the school looking over. The solder has our backs a bit. Okay, I'm gonna start again. You guys good? You guys good to start again? Yeah, okay. IT architecture and cloud computing, two pretty important concepts, but we don't go too in depth into either of them in this course. So, explain the relationship between business strategy and IT architecture. So, inherently, between the people who work on the technology side of things, doing the IT work, building the software, versus the professionals who are doing sales, doing business strategy, and that kind of stuff, there's a very different cultural mindset, right? They have different cultures. They also have very different goals and objectives, right? If you're the guy building the software, you want to make the best, most efficient piece of software you can. Whereas if you're the guy on the sales team, you want to just sell as much stuff as you can, right? So there's two very different, goals, mindsets, values there. So an issue that can happen is that the IT guys don't know how the business guys want things made, and the business guys don't know what can be made by the IT guys. So this is the relationship mainly between business strategy and IT architecture. So the solution is, how do we build technology? So you either make sure you build your technology around the business guys and their business strategies, and you build your strategies keeping in mind strongly your IT capabilities. It's just this mutual relationship between these two cultures and two divisions of your company. They need to both stay in check with each other, otherwise you're going to run into big failures because you're going to not really know what your company can build, or you're going to be trying to build something that you can't even build. So it needs to be a mutual understanding between the two components, as well as the business strategy must be clearly communicated, as well as the IT architecture must be understood by the business guys. Architecture is a very fancy of a word. It literally just means like the technology available in the company, right? Which is the policies and the goals and the capabilities of the IT department of the company as to what they can build. Policies are like what kind of projects we take on. Goals are like, do we focus on efficiency versus putting out the most things? So just making sure those two align is something very important. If you don't have successful alignment between your IT architecture and your business strategy, you're setting yourself up for failure. So yeah, having it clearly communicated of both is a great solution to bridge the gap. Cloud computing, in the context of this course, cloud computing is like a super complex technical thing, but that's not what we talk about in this course. We talk about cloud computing and its applications to transfer information all around the world rapidly. So you have a shared pool of technology resources available at any time across the entire world. Let's think about Google Docs as an example of cloud computing, because that's exactly what it is. It is a software as a service. So you can use Google Docs anywhere in the world, have the exact same access to the exact same thing because it's on a cloud platform. So what do we mean when we refer to cloud is that's not done locally on your computer. You're connecting to a server, and whatever you're doing is on that server, and the database and the data from it isn't stored on your computer. It's stored over there, so it can be accessed by everyone from anywhere. Not anyone, but like anyone in the company or whatever the scope is. But it's not like exclusive, like it's not tied to your physical computer. I could turn off my computer midway through, hop on my phone, and potentially access the same thing. That's the concept of a cloud in this. That's just straight up the concept of cloud computing, is that it's things that are not stored locally. Instead, it uses a shared pool of technology in a centralized location. And the benefit is it allows transfer rapidly, anywhere, anytime. That concept of cloud makes sense? Slide explanation? Okay. Then there's three main operations. You're probably going to need to know the difference between all of these. There's some confusion between infrastructure as a service and platform as a service. I'll go through each of them. IaaS, infrastructure as a service, is being able to use computer hardware on the cloud somewhere, like on the fly. So like as I said, like cloud computing, right? So what I can do is instead of running my highly intensive program on my computer, I can run it somewhere else. So infrastructure as a service just gives you literally the hardware to run something not locally. The main difference between infrastructure as a service and platform as a service is what you're probably going to want to be more interested in. Platform as a service is you get a full-on solution somewhere else already. Whereas infrastructure as a service is you're just running your own software on their computers. Whereas platform as a service is you get the software and the hardware all together already there. You can Google some examples. I probably should have. That's something we'll do afterwards. So examples of platform as a service. So yeah, one is just the bare bones hardware capabilities that you're wanting to use. Like say you're a game development company, okay? To run like a high-end game, you need some pretty heavy computers, right? What if you guys can't afford those? So what do? The main solution is you run your game on someone else's computer. You're not going to want to borrow someone's physical computer, so you can do it virtually using cloud computing. You can run your game on someone else's computer out there, which is super high-end, and that's your solution. Whereas platform as a service is that there is this like suite of technologies that are super good and super beneficial to my company, like a game development program that's made by some company, but my computer is not capable of running it. I'm just on like a shitty laptop. So I can log on like remotely using the internet to go on their computer, use that software, but it's not running the software on my computer, it's running the software on their super high-end beefy computer somewhere in the world. So that's the concept of this is straight from the side of the shared pool of technology resources. So I'm not running it on my thing, I'm using their resources. So the second example of the game development software that they have is a platform as a service. That's their platform. IaaS is like, I want to run my game on your hardware, right? So IaaS is more bare bones. It's literally just the infrastructure. Infrastructure is the hardware. It can be done. See, the beauty of it is it can be done through anywhere, as long as you have internet. The beauty is that as long as you have internet, cloud computing can work anywhere.
So if I want to run my game on someone else's computer,
yep.
What would that mean? Like I'm logging into their computer to my own?
So it's, yeah, that could be it. Like that's straight up a thing that can be done. But like the main solutions that one would see from a user perspective is it actually exists. What I was talking about, this game thing, actually fully exists. In that there was this like game rental company for online PC games. You can't run most PC games on a random laptop, but you would download like their software and you could run the game on their laptop. So it's the main thing that the course talks about is the cloud computing aspect, not like the actual user interface stuff, but the main differentiations I was going over there is infrastructure as a service is using someone else's hardware. Software as a service is you're just using an online application of theirs, like NetSuite ERP, software as a service. Hootsuite, software as a service. Google Docs, software as a service. Yep.
So it's a PA,
Yeah, not really, because the terminal has the hardware. Pardon? Yeah, so they're like terminals are like specific PCs that like have all the software already on it and the stuff computed locally. Yeah, it's more software as a service component. Platform as a service. Yeah, I can't think of too many full examples, but we'll find some real world examples. Platform as a service. The main thing you need to know is that everything gets done somewhere else with platform as a service. Software as a service is you're literally just using some sort of like application online, like Hootsuite or like Google Docs. And then IaaS is you're literally just using their hardware. A big usage of IaaS is that a lot of companies. So the biggest thing that IaaS is used for is web hosting. So Amazon Web Services. Is this that video? Is this? I think this is that video. No.
Whether you're working in retail or real estate, with financial data or photos, your business depends on applications that run reliably and securely at a cost that scales with your needs. Amazon Web Services provides a complete set of cloud computing services accessed via the internet to help you build and run those
I'm gonna put the sound up
applications.
there, okay? Sorry, it's just like probably better for you guys. Amazon Web Services, it might come up, but now you'll know what it means.
At AWS, we provide compute, storage, and database services which enable your organization to quickly provision the IT resources it needs without significant capital investment. Pretty much everything you would want to do in a traditional data center is available with AWS. But all our services are available on a pay-as-you-go basis with no upfront capital expense. Instead, you'll find highly durable storage services, low latency databases, and a suite of application development tools which you'll only pay for as you're using them. Since AWS has hundreds of thousands of customers across 190 countries, you'll also benefit from our economies of scale, delivering powerful resources at a low operational cost. Capacity planning becomes easier too. In a traditional data center, launching a new application can be a bit of a gamble. Provision too many servers, and you could end up wasting money and time. Provision too few, and your customers might not have the best experience. With the ability to add and remove capacity elastically, your application can scale up to meet your customers' needs and scale back down again quickly, saving you money. And while we could talk about provisioned I/O performance and durability statistics all day long, we often hear from customers that the biggest performance improvements come from their own team's ability to deliver innovative new features to market more quickly. With AWS, development teams are able to focus on adding differentiated value for their own customers rather than on the heavy lifting of racking and stacking servers. This helps drive innovation by making new ideas feasible that were once out of reach. Experimentation is fast and low risk, making it possible to try out new projects which would once have been constrained by cost or resources. Successful experiments can go into production quickly, and you won't have to live with the collateral damage or cost of those that didn't pan out. In today's interconnected world, it's possible for any company to have end users across the world. From our multiple geographic regions, AWS helps businesses serve their customers globally without the need for expensive, time-consuming physical geographic expansion.
Cool. Wow, he did a better job explaining it than I could have, so that was good. But you guys get that? So the main benefit of using cloud computing is that I don't have all these heavy upfront costs. Do I have a slide on this? Nope, I don't. So just at the end of this is that I don't have all these heavy upfront costs. What that means is if I am a small startup, right, and I want to develop a game, okay, I need all these expensive high-end computers. I need a database to store all this information. I would spend thousands and thousands of dollars to purchase that equipment, and then my company could fail. I lost all this money. Whereas using cloud computing, something like Amazon Web Services, I could use their stuff, their technology already existing, and develop on theirs, test on theirs, deploy on theirs, without having to go up with those upfront costs. And it's all a pay-as-you-go type service type thing. So if my thing becomes successful, it's very easy for me to scale that up because I can just buy more space on Amazon Web Services. Or if it fails, what's my loss? Just what I've already just paid on it, rather than all these upfront sunk costs. Pretty cool concept and definitely very, very powerful. The concept of economies of scale he mentioned there. They have a bajillion users across the world, so they have the ability to buy and create these giant data centers at a much lower cost than you would buy just a single data suite center thing. So economies of scale, Econ 102, COMM 295. Okay, IS development and project management. We're near the end, so stick with me. Describe the seven phases of the SDLC, acronym that you're probably going to get thrown at you. What is the SDLC? See, I'm wrong right off the bat. System Development Life Cycle. So System Development Life Cycle is what SDLC stands for. There's 7 main phases. Let's go through those phases. There's the planning phase. We establish the main goal of the project. Is the project feasible? What will our system accomplish? So that's the planning phase. Analysis phase. We'll think of an acronym for it afterwards, because you need to remember these 7 phases. You may have to go through an example, like your company. Let's go through your system development life cycle to plan out this new product you're doing. So you need to know these 7 phases: planning, analysis, design, development, testing, implementation, and maintenance. In the analysis phase, we got to think of what functions will we actually be providing. We need to then create a systems requirement document. So the beauty of these phases and the way YM has presented it is each one has almost like something you take out of that. So something that is then created as a result of that phase. So the creation process in the analysis phase is you create a system requirements document. What do we need to make this system be built, to actually make the system? The design phase, big decision that comes out here is the make or buy decision. You don't go in depth on this. You probably did in COMM 294, right, about make or buy, that concept. So pretty straightforward. Do we want to buy it or make it, which is more cost effective, which will do better for our system that we need? How will the system actually work? And architecture related decisions, like literally just designing what the system will be like. Development phase, we either buy it or we bring it in. Development and testing are kind of looped together because they're so interdependent. So after development, we need to test it. Test the shit out of it to make sure it works for our company. So test it extensively, pretty straightforward on that phase. Implementation. This to me is one of the most important phases. And you might want to stress that as well. Because now you have this new technology that your company is going to be using. How do we make sure all our employees know how to use it? Well, that comes from extensive training sessions, testing, creating user documentation, the whole 9 yards. That's the implementation phase, and that's super important to stress upon. Last but not least is the maintenance phase. Things break. Bugs arise that you didn't think about when you're doing the testing phase. And you always want to continually be making any system you have better, updates. So that's the maintenance phase. Perform updates to keep competitive and keep your systems up to date. Then the main development methods. So this is, I don't know how he tested this last semester. It might be a multiple choice type thing, but it could be, and it is fair game for a short answer as to which one you would use. So let me tell you off the bat, waterfall is very seldomly used. It's super traditional. It's very sequential. It's like, so first we're going to do all the planning, and then we're going to do all this, and then we're going to do all this. Like the structure is literally a waterfall, and everything waits on the thing before it. It's the least efficient, and it has the least flexibility in that you've done all this pre-stuff before this. So if you want to change something down here, you're going to have to redo all of the previous steps. Waterfall is probably not something you're going to, if you were to be answering a short answer question, waterfall is probably not the solution you'd be suggesting. Make sense? Are you going to announce now? Okay, cool. Then prototyping. So prototyping, as well as rapid application development, again, not the one you're probably going to be asked to recommend, but we'll go over them each. We didn't even go over them last year because they were just irrelevant. Prototyping is, you get the user requirements first, right? You take the user's input, you build an initial version, you get some more user involvement, you show them that initial version you made, and then you make the final product. Rapid application development, it uses, it's very similar to prototyping, but there's a lot more user involvement. And it's not just like a one prototype and then you make your final product. It's like prototype, okay, let's change something up a bit. Prototype, change something up a bit. And then agile. So agile is just straight up, we make an MVP, a minimum viable product. That's what that stands for. We make the most basic solution first. And then every week we make a brand new iteration of it. Iteration just means like an updated version. So we constantly perfect the product And the beauty of agile development's used like all over the place, by the way, these days in almost every startup. They're all about like agile, right? It's just almost like a buzzword at this point. Agile is it allows constant user input every like most like so it's called a scrum in a sprint. Depending on the company, the sprint will be a different length. But every sprint is at the end of each sprint, the company comes out with a brand new iteration, right? And during that sprint, you have the time to get user feedback, user information, and implement new features and all that kind of stuff, and have that released at the end of each sprint. So that's agile. Yep. MVP stands for minimum viable product. Minimum viable product. That's the most bare bones solution that you can have that works. So if you're ever doing a recommendation thing, you'd probably be trying to recommend agile, and then you're going to tell why it's good. So the difference between each of these is one, the biggest thing is the user input, right? How much of a sunk cost do you have? Like how hard is it to change the direction that you guys are going or change what your product is? Agile gives you the most flexibility because every week or every 2 weeks, you're able to create like a new iteration of your product. Whereas waterfall, you create one big product, and at the end of it, if you're unhappy with it, well, too bad for you. Prototyping, again, not something that's very much used now that agile is around. Prototyping and rapid agile application development are just like subsets, almost like lesser versions of agile. Whereas agile is the most hardcore, like we're going to constantly make our product, right? There's tons of really nice videos on agile development. I suggest you watch at least one video on agile development. There's some like 5-minute ones, so you understand the concept some more, some of the terminology around it. So do check that out. The fundamentals of project management. So you're going to want to know why projects fail so that you don't make your projects fail. And the biggest reason that we went over in this class is scope creep. Scope creep terminology, know that terminology. Scope creep is that as you're building your product, you're going to want more features. You're going to constantly want more features and make the product even bigger and better. At some point, your scope is going to get so big and all these features that you want are going to be so big that's going to outgrow your capabilities. So you have to very clearly define your scope of what you're going to build so you can actually achieve it. Because otherwise you're just never going to achieve it. So that's the concept of scope creep, is to make sure you have your scope of the project and the goal of the project very well defined from the get-go during the planning phase and the analysis phase so that you don't run into scope creep. Does that make sense, the concept of scope creep? Cool. Also, ask questions as you have them. Don't be scared, because I'd rather have you know what you're doing than not. A project manager, the role of the project manager is to make sure the project succeeds, right? That's their fundamental goal, make the project succeed. Now, how do they do that? They use a bunch of different tools. One of the main tools they use is a Gantt chart, which is a tracking chart of like deliverables and milestones that the project has to keep it on track so that it hits its goal. So it stays within its scope and it hits its goal. A project manager really just guides the development of whatever the project is towards its success. Because as we mentioned earlier, if you don't keep track of your scope or what your end goal originally was, you can go so far off your end goal and then your project just is going to fail, right? Terminology here, Gantt chart. You might be asked what a Gantt chart is. A very good example in your slides of what it looks like. It basically is a chart of a bunch of bars, and it just keeps track of like, at this point in time, we're going to be focusing on developing this. At this point in time, we're going to be focusing on making sure our product can do this. And then like it has like a timeline. It's basically a timeline. Check the example in the slides of what a Gantt chart looks like. It just is a way of clearly outlining what the deliverables of the project are. Okay, last slide, information, security, privacy, and ethics. Explain what information ethics and information privacy are. So ethics in the scope of this course is you have a lot of really sensitive data. You can do a lot of really really unethical stuff with this data. You can like see who's flirting with who on Facebook Messenger by looking through all their Facebook messages. Like imagine that. You're like some dude who works at Google. You can see Donald Trump's search history. Like that's a lot of power, right? Because you can track this kind of stuff. So that's where ethics in the scope of technology come into play. It's making the right and wrong decision, or differentiating what the right and wrong decisions to do with personal information are. So companies have a very strongly defined code of ethics. An example I'll give you is at Google, right? Their code of ethics makes it so that no employee, so basically there's 3 things you need to identify who someone is on Google internally, right? Using like the database stuff, determine who a user is. Every software engineer only has access to 2 of these 3 things. You can't find out who someone is without that 3rd component. It could be something like geolocation, IP address, and like user ID or something like that, which is to somebody who doesn't know what they're looking at, it means nothing. But if you have all 3 together, you can very precisely identify whose search information that is. So that's like an example of a code of ethics in action, in that they have this code policy where like only 2 people, like you can only see 2 components of those 3, so you can't identify who someone is. So code of ethics is just how you deal with your sensitive information within your company. Information collection, there's 2 major models. An opt-in model. So when you sign up for a website, when you create your account on Facebook, like you're automatically opting in for Facebook to collect your information, right? You're signing up for an account. So opting in is explicitly saying, take my information. And most things are opt-in. You're automatically opting in. But some places, they have an option for you to opt out from your user information being collected. So some websites, they'll be like, yeah, we track your cookies. If you don't want us to track you, click this. So that's an opt-out model versus opt-in. It's just as straightforward as that sounds, like opt into your data being collected versus opt out. Yeah, 2 different models, terminology that you may be questioned about. Describe information security and explain why people are the first line of defense in terms of protecting information. So you have all these databases. It's actually really hard these days for people to hack into a database and like get someone's information, just because of like the scale where technology is at these days. So the biggest vulnerability actually is, say you have an employee. The employee like loses their laptop. That's a really, really big vulnerability now, because that laptop now has access to that database that someone public wouldn't be able to access normally, but now somebody can. So that's this idea of data privacy and security, in that rather in like the concept of people being the first line of defense. The hard way to get into data is through technology. The easy way is to get access to it through somebody who already has access to it by like getting on their computer. Or a big thing that you guys talked about probably is like social manipulation. Like you can trick somebody into letting you use their account. Most people, when they say like, or their Facebooks get hacked per se, the reason is that they clicked some link that took them to a website that looks just like Facebook, but the URL actually isn't Facebook. It's like facebook.russia.blah blah blah, some like random URL, but it looks just like Facebook. So they literally log into there and they're like, oh, my login didn't work on here, but you literally just gave your login information to some company that's going to now go into your account and like hack your, like make you post spam. Exactly. You literally get, and you probably get text messages from like BMO saying your account was like suspiciously accessed, but it's not actually from BMO. So that's how like people are so vulnerable. Like my mom has like almost gotten her email hacked like 1 billion times as a result of things like that. So that's this concept of people being the first line of defense. So how do you deal with this? Training and education to stop social engineering from working. Because you and I now know about this. If everybody in your company knows, like, hey, every email from our company will have this exact structure of email address, that's an example of training, right? So ways to make sure social engineering is not an option for people to hack our company's information. most of these giant leaks that have happened are as a result of social engineering. Somebody in the company doing something wrong that gives somebody else access to everything, or things like that. It's not by some crazy ass hacker hacking into the White House's resources. It's somebody at the White House losing their badge that has their ID on it. So companies are the ones liable and responsible for dealing with all this information. Because you're the one who collected this information in the first place. It's your responsibility to ensure that you have privacy measures around this information, this personal information that you've been entrusted with from your users, to make sure it doesn't fall into the wrong hands. And those are the main concepts of information security. Keep private and personal information secure from unauthorized access. How do you do it? Well, the main thing that we talk about in this course is preventing social engineering. How do you do that? Education and training. Then there's also technology solutions, which you don't really go into this, but it's kind of just oh yeah, firewalls and things like that, but not something extensive in this course. So that's all the stuff in the slides that got covered. There are two major assignments, which was the NetSuite ERP assignment and the FileMaker Pro assignment. The main things you should have got out of those is NetSuite can do a lot of things. You can be you have to go into all the different roles. You have to see all those different roles. That's actually how it works in a company, is that all these different people would use this one software to do complete their own business processes, but it's all centralized and it's all easily accessible and it streamlines processes. And then the FileMaker Pro assignment showed you all the beauties of a database and that you can make it relational and you can do all these things. Cool. That's all I had to say about this. Ask me questions, stick around, I'll be here. Ask me questions, we'll go into slides. We'll Google a lot, because I had to Google a lot when doing this. Yeah. That's all the content. I mean, we literally went over every learning goal of this section. And those learning goals further encompass those review questions. Make sure you feel comfortable with each of those review question concepts. My homework to you, if you plan to come to office hours tomorrow, look through those review questions and circle the ones that you don't understand. Then tomorrow we will solve your problem. If you have a question that's you're dying to ask, instead of directly Facebook messaging me, which you're welcome to do, but it's just easier if you post it on the event page, because someone else probably has the same question. And it's easier for me to track it, because a lot of people messaged me after the last one, but it got lost because I had so many messages coming in. So just post it on the event page. Cool, that's all I had to review with you guys, but I'm here to answer questions and clarify concepts. Questions? Yeah, I mean, I think I already have them set. They're for tomorrow, I just need to double check. If you give me a sec, I'll tell you what time. Any other questions while I'm looking this up? Yep.
One of the questions on this is, what is the relationship between software and information? And software is one of the components.
Of an information, exactly. Yep. So it's one of the main components. So there's hardware, software, there's people, there's technology, there's databases. Is databases one of those components? But it's listed on the slide. There's this slide which has the orange and green. Here, we'll pull up that slide to make sure you know exactly what we're talking about. Yeah, people's the biggest one. People. Yeah. So it's this. These are the components. Right. Okay. 1 to 3 p.m. tomorrow. 1 p.m. to 3 p.m. tomorrow. HA 194. HA 194. 1 to 3 p.m. tomorrow. Bring me questions. A nice way to study for this is that there's just a ton of videos of really smart people explaining this stuff. Some of it is out of the scope of this class, but it's better to know more than know less. So Like some of these things you don't understand, YouTube them. Like straight up, listen to some like smart old guy explain it, because you'll learn a lot.
What was the short? What was the short answer?
I don't remember exactly what they were.
194, right?
Pardon? 194. Yeah. Yeah. Because you do the exam, you're done.
Does anyone actually go through the question? Does anyone actually answer these questions? Does anyone actually go through it?
Oh, the other thing he told me is like you're not going to get any of those questions directly. Like he's not going to ask you that question directly. It's more going to be like embedded in like a short answer question, or like the multiple choice stuff is mainly like terminology. I want to say it's mainly terminology related stuff. Like it's some conceptual stuff on the multiple choice, but like for the most part, it's just understanding what the terms actually mean. Whereas the short answer is where this knowledge of the concepts and how they connect really comes into play. No, like both clickers and ICE were like ICE for the first component, like are way harder than the content on here. If you don't have access to those clicker questions, right? Yeah, neither do I. So they're don't worry about those. Just worry about the contents in here. Yeah, and those questions. It's very nice of him to provide those review questions because it really helps you out. But don't tunnel vision on those. It's more about knowing the concepts covered in those questions. Because you're not going to have any of those questions directly asked you. And we covered most of them. We covered a lot of them in here. Like they're embedded into the learning goals and into the slides. So, Amin, what are the differences between IS and IT?
IS and IT information system is it's like the bigger based information technologies inside.
So, what does information technology refer to?
Information technologies, the hardware and the software, and like the physical components required.
The main word you should know about is tools. Tools. Like the IT is actually just like the tools that they use, whereas the IS encompasses everything. But yeah, the hardware, the software is a component of the IT. IT is a subset of IS, and it's the tools that are used. When like in the slides, that's the main like word he uses. So just try and like use his own words. We just went over some of these harder ones. Audit trail. I went over an audit trail pretty in depth. Or Anna, what's an audit trail? Yeah, let me give you the full question. In transaction processing systems.
Whenever there's transactions being completed and you're going to want to report them using the transaction processing system to keep track of everything that's being done.
Mm-hmm.
So the audit trail is basically the record of all the transactions that it's reporting in the system.
Mm-hmm. You're on the right track. What can I get from those pieces of information on the audit trail?
Like what happened at what point in time in
Yeah.
the process.
Yeah, so like I could see who generated what. Who is a big component as well. In NetSuite specifically, there's a lot of like who is the owner of this, who generated this transaction. So you can see who did it, when they did it, why they did it, and you can just like track all transactions that happened. Yeah, that's exactly it though. Costs and benefits of an ERP solution. Michael, do you want to answer that? What are the costs and benefits of ERP systems? So like main costs are that there's like straight up one, like an actual cost. You have to pay a company to implement your ERP solution. Another big cost of an ERP system is that you need to train people how to use it. And then the main benefits is one, you get aggregation of all your business processes into one system. You optimize your processes, you make, no worries, thanks for coming. You have more efficient processes. It's just easier from a management perspective. That's number 8 in Unit 3. Cool, I'm not going to grill you guys anymore. So, you guys are welcome to go, but I'm here. So thank you very much for coming.
Is there an online?
Yo, you won $10. Yeah. Oh, and also this was all recorded, so if you like really want to listen to something again, you can check it out. It's on Commerce Mentorship Program on YouTube, and you can find it on our event page as well. So this was all recorded live, so your questions are also recorded. So holy crap, it went into like